You've chosen this video because you want to learn how to solve rational equations. When you have an equation that looks like this, and there's nothing added or subtracted on this side, nothing added and subtracted on this side, and since there's an equal sign here, you can actually just cross multiply. So you can multiply 3 times a and set that equal to a minus 8 times a plus 5. Since we need to set this equation equal to 0 in order to be able to solve it, we're going to FOIL this out because we're going to have to combine our like terms and subtract this 3a. When you FOIL, you have a times a squared, plus 5a, minus 8a, minus 40. Now we'll subtract 3a on both sides, so that we can set the left side equal to 0. Here we have 5a minus 8a, and that's negative 3a minus 3a, so that's minus 6a. Now that we have a quadratic and it's set equal to 0, we can factor or use quadratic formula to solve for a. If you need help factoring, please check out my other videos on factoring. We need to find two numbers that multiply to negative 40 and add to negative 6. What are those two numbers? Negative 10 and positive 4. You can see, just to check this, that this would be a squared and then plus 4a minus 10a. That will give us our minus 6a. And negative 10 times positive 4 is negative 40. Now that we have it in factored form, set equal to 0, we can set each factor equal to 0 and solve. So we can set a minus 10 equal to 0 and a plus 4 equal to 0. Add 10 to both sides, then a equals 10. Subtract 4 on both sides, then a equals negative 4. Now on these, it's very important to check your solutions in the original equation and make sure that neither one of these would make the denominator 0. So 10 is not going to make your denominator 0, and negative 4 is also not going to make your denominator 0. But we can plug in 10, and we would have 2 over 10. And if we plug in 10 here, we would have 3 over 15. And we know that 2 over 10 is equal to 3 over 15 because they both simplify to 1 over 5. So that's always a great way to check whenever you're solving equations. We'll plug in negative 4. We have negative 12 over negative 4. Is that equal to 3 over negative 4 plus 5? Negative 12 divided by negative 4 is positive 3. 3 divided by 1 is also 3, so we know that those are correct. Let's look at another example. Here's our second example. Now this one is different from the first one because we do have two fractions that are added here, so we cannot cross multiply because this would need to be one fraction in order to cross multiply. Now we can see that our denominator here is 2n, and then this denominator is n squared, and this denominator is 2n squared. So we're going to find our least common denominator, and that would be 2n squared. So if we multiply this fraction here by n over n, and this fraction here by 2 over 2, then we can have the same denominator in each fraction. When we multiply this together, we'll have 2n squared, and 2n squared. So that's the way that we're going to approach this problem. So then we're going to multiply the 3 times n, and that's over 2n squared, plus 2 times 1 over 2n squared is equal to n minus 2 over 2n squared. So this fraction already had the denominator 2n squared, so we didn't have to multiply it by anything. We just multiplied the numerator and denominator by 2 here, and this one by n, so that we would have a common denominator for each one. Now we can write this as one fraction since we have a common denominator. So we can say 3n plus 2 over our common denominator. And now there's really no need to cross multiply because we have the exact same denominator on both fractions. And if these are equal and the denominators are equal, that must mean that the numerators are equal. So we can just drop the denominators since they're already equal, and we can just set our numerators equal to each other and solve for n. So we'll subtract n on both sides, and we'll subtract 2 on both sides, and then we'll divide both sides by 2. And our answer is n equals -2. Very important to check and make sure that -2 for n would not make any of our denominators 0, because if it did, then we would have no solution. We can also plug it in to check our answer. Always plug your solution back into the original equation. So we have 3 over -4 plus 1 over 4 would equal -4 over 2 times 4 is 8. So here, this negative can go in the numerator, because if a fraction is negative, that means that it's either the numerator or denominator. So we definitely want the numerator to have the negative in this case, because that way we will have, I'm going to go ahead and simplify this -4/8 to -1/2. But that way we have a common denominator here, so we can add our numerators together. So we would have -2 over 4 is equal to -1/2, and that is true. Let's look at 2 more examples, but thank you for choosing Math with Caroline. Please give a thumbs up if you're learning, subscribe, share this video with your friends, and leave a comment. I would love to hear from you. In this example, this denominator is already factored, so we can look for our least common denominator between all 3 fractions. So we have p minus 1 here and p minus 1 here, and we have a 3 here and a p minus 6 here. So our least common denominator will be 3 times p minus 1 times p minus 6, which means that we're going to have to multiply this fraction by 3 over 3, this fraction by 3 and p minus 6, and this fraction by p minus 1 and p minus 6. Now, of course, it's important to multiply the numerator and the denominator of each fraction. So this is going to give us our common denominator. This will have all 3. Now this will have all 3, and this will have all 3. So what we're going to do is, since we're going to have to combine like terms, we're going to distribute this 3, and then we're going to distribute this 3. So let's go ahead and do that. So we're going to have 3p squared plus 3p plus 24. And then we're going to multiply 3p minus 18, and that's still times 2. So I've just distributed this 3, so I've got 3p minus 18, and then that still needs to be multiplied by this 2 here. So I'm going to do that in 2 separate steps. And then this one, I'm going to go ahead and FOIL the p minus 1 and p minus 6, and then I'll multiply by 2 afterwards. So we'll leave that 2 in the front, and then p minus 1 times p minus 6 would be p squared minus 6p minus 1p, so that'll be minus 7p. And then -1 times -6 will be positive 6. Now I'm going to go ahead and leave the denominator off because I really I showed it in the last example, but I really don't need to write it, because since this is going to have a common denominator with this, I can combine all these numerators here. And then since this denominator is going to equal this denominator, that means that my numerators must be equal then. So at this point, when I use this strategy, I can just leave this denominator off of this problem, and that saves me time and space. So now I'm going to distribute this 2 and distribute this 2, and then I'm going to work on combining like terms. So distributing the 2 will give me 6p minus 36. Distributing this 2 will give me 2p squared minus 14p plus 12. So I'm going to combine like terms. I'm going to add up this 3p and the 6p, and then combine the 24 minus 36. So I've got 3p squared plus 9p minus 12 is equal to 2p squared minus 14p plus 12. Now I want to set my equation equal to 0. So I'm going to subtract 2p squared on both sides, add 14p, and subtract 12. So when I subtract 2p squared, I will have 1p squared. When I add 14p, I will have 23p. And when I subtract 12, I'll have minus 24. Now that my quadratic equation is set equal to 0, I can solve this by factoring or quadratic formula. What are the two numbers that multiply to negative 24 and add to 23? 24 and negative 1. So those will go in my factors. I could always multiply this back out to check my work, but I will have plus 24p minus 1p. That will give me my positive 23. 24 times negative 1 will give me my negative 24. Now I can set p plus 24 equal to 0 and p minus 1 equal to 0. Subtract 24 on both sides, add 1 on both sides, and I get my two solutions. And then I'm going to check and make sure that neither one of these would make my denominator 0. Well, if I plugged in p equals 1 into this one, it would make my denominator 0. So this ends up being an extraneous solution. So that actually will not count for my solutions. And I'm only going to have the solution p equals negative 24. Let's do one more example. In this example, we can see that our least common denominator will be 3 times 4v plus 3. So we need to multiply this fraction by 4v plus 3. And this fraction by 3. So I'm going to go ahead and put this in parentheses, very important, so that I remember to distribute this 3 to both of these terms. And this fraction already has the least common denominator. So now that I have a common denominator here, here, and here, I'm just going to drop it like I did last time. And I'm going to go ahead and multiply my numerators. So I have 4v plus 3, since that's just being multiplied by 1, and then minus 3, since that's 3 times 1, equals v squared minus 3v minus 18. Now I want to set this equation equal to 0. So last time I subtracted everything and had my quadratic equation on the left. It doesn't matter if it's on the left or on the right. What I would really like is that my quadratic term is positive. So I'm going to leave, in this case, I'm going to leave everything on the right side since I already had this v squared. So I'm going to subtract 4v on both sides, and this 3 minus 3 right here is just 0, so I'm not even going to have to do anything with that. So I'm going to subtract 4v on both sides, so I'll have minus 7v, and then I have my minus 18. Now I'm ready to solve a quadratic equation since it's set equal to 0, and I can do this by factoring. Two numbers that multiply to negative 18 and add to negative 7 are negative 9 and positive 2. So those are the numbers that go in my factors. And now that it's factored, I can set each factor equal to 0. Add 9 to both sides, subtract 2 on both sides to get my two solutions. Then I'll check and make sure that neither one of these would make a denominator in the original equation 0. So if I plugged in -2, I would not get 0. If I plug in 9, I would not get 0. So both of those are solutions. I could, of course, go further and really plug in the 9 for all the v's and make sure that both sides would be equal to each other, and then do the same thing with the -2, plug that in for all the v's, and make sure these sides are equal to each other. I would definitely do that on a quiz or test. Please also check out my other videos on simplifying, multiplying, and dividing rational expressions by factoring, adding and subtracting rational expressions, which also includes factoring, and graphing rational functions. Thanks again for choosing Math with Caroline.